Hi everyone. I thought we would spend a little bit of time talking about frequency tables, how to make frequency tables, the different types of frequency tables. So let's get started. Grab some paper. Okay. Suppose we have the pulse rates taken of 40 different people, and we want to make a frequency table. A frequency table is really just a table that gives counts in some kind of order that makes sense. And so our first step is to go through to figure out how many classes we need, how many rows that we need in our table. So you would find your range. Range is high minus low. So our range, 124 minus 60 would give us a range of 64. And then decide how many classes that you want to have. Usually it's somewhere between 5 and 20. 5 on the low end, less than 5, there's not really a lot of point to it. 20, there's way too many rows to keep up with. And so looking at our data, we have 60s, 70s, 80s, 90s, 100s, 110s, 120s. So we're going to decide to have 1, 2, 3, 4, 5, 6 different classes. 1, 2, 3, 4, 5, 6, 7 different classes. So let's divide 64 by 7, and we get about 9.1. And you always round up. Even if it came out exactly 9, you have to round up to get both of your numbers on the end. So we're going to round this up to 10. So if we want to have 7 classes, we're going to put 10 numbers in each class. And so here are our 10 numbers. 60 to 69, that's 10 numbers. 70 to 79, that's 10 numbers. And I'm counting by tens. 60, 70, 80, 90, 100, 110, 120. You're counting by tens. So let's talk about the vocabulary that goes along with this. We would have gone through and found the frequency. Frequency is just counts. How many 60s do we have? 12. How many 70s do we have? 14. 80s, we have 11. 1 in the 90s, 1 between 100 and 109, none here, and 1 at the end. Okay, more vocabulary. Okay, lower class limits are the smallest number that can belong to any class. So in our case, our lower class limits would be 60, 70, 80, and so on. The smallest number in that class is a 60. Upper class limits are the largest numbers. So in our case, our upper class limits are 69, 79, 89, and so on. Okay. Now, if we were graphing that, it's hard to graph 60 to 69 and then start right at 70 and go 70 to 79. So we need some other tools that we can use for graphing if we're going to make a histogram, a bar chart with this. So we can use a couple different things. We can use boundaries. Boundaries are like what I call round-off numbers. They're used to separate your classes. So going back and looking at ours, 60 to 69, 70 to 79. Now these are pulses, so you don't have like half of a heartbeat. But if these were grades, like 60 to 69, 70 to 79, and you made 69.8, which class would that be in? The 60 to 69 or the 70 to 79? 69.8 would round up. Anything above 69.5 rounds up. So those are our boundaries. 69.5 would go here. 79.5 89.5, and so on. The only weird thing about boundaries is you also have to have one at the top and one at the very bottom. So we would also have a boundary of 59.5, and then down here at the bottom we'll also have a boundary of 129.5. So those are our boundaries, kind of like round off numbers. So ours went 59.5, 69.5, all the way up to 129.5. Midpoint. When you think of something in the middle, like if you had two numbers like 60 and 70, and I'm like, what's in the middle? That'd be 65. It's the average of your two numbers. So midpoints are the values in the middle of your classes. So you can think of those, if things are in the middle, it's like the average. So you can think of them as your average points. So for us, to get the first midpoint, our first class went 60 to 69. So 60 plus 69 divided by 2 gives us a midpoint of 64.5. Halfway between 70 and 79, we will have 74.5. So those are our midpoints, and we will use those next week when we start finding the mean and the median on frequency tables. So you'll need to be able to find midpoints. Super, super important. Okay. Class width. We decided this at the very beginning. When we had 9.1, we rounded it up to 10. 10 is how big our class is. It's also the difference, meaning like subtracting difference, the difference between two consecutive lower class limits or two consecutive upper class limits, not the difference in the same class. So to get our class width, we could say 70 minus 60, 10. 80 minus 70, 10. What you can't do is this. You can't say 69 minus 60 is 9. So can't do that, because between 60 and 69, count with me, 60 to 69, 60, 61, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 numbers in the class, and that's what class width is. How much is in your class? Okay, so brings us to two other types of frequency tables. We have relative frequency. Relative means that it is a percent of the total. Percent of the total. Okay, so let's go back and look at our charts. Okay, so if we would go through and we add all of these together, 12 plus 14 plus 11 plus 1 plus 1 plus 1, we will get a total of 40. So relative frequency is what percent of 40? So we'll have 12 out of 40, 30%. 14 out of 40, 14 out of 40, 35%. 27 out of 40, and you can round these to maybe one decimal place, 27.5%. 1 out of 40, 2.5, 2.5, 0, and 2.5. Okay, when you add those together, they will add up pretty close to 100%. Ours came out exactly 100% because dividing by 40 is not strange, but what if we had 41 or 47? Then we would get a bunch of decimals and we would have to round off. And you get a little bit of round off error, so it could be anywhere from like 99% to like 101%, depending on how you rounded things off. And that's okay, but pretty much it's going to be close to 100. Cumulative frequency. Cumulative frequency you can think of as like a running total. If we had a test and it is cumulative, it would cover everything that we had done for the entire semester. Everything that we're doing this week, everything we did last week, everything we did before. So a cumulative frequency, we add it up as we go. So, and a lot of times you'll see it written as less than 69. How many people had a pulse less than 69? 12. How many people had a pulse less than 79? 14, plus the 12 that was in the 60s. Okay, 80 to 89. We've got 11 more this time. 14 plus 12 plus 11. So 37 plus 1 more is 38, plus 1 more is 39, plus 0 is 39, plus 1 more is 40. So cumulative frequency is a running total. Okay, so this is a nice way to present your data. There are some other ways that we can present data as well. We can do a stem and leaf plot, and you may have done these before, like a long time ago, like 8th or 9th grade maybe. But a stem and leaf plot, for our case, we will have the tens and then we will have the ones. Let me see if I can copy this data so we don't have to keep flipping back. Okay, so here's our data. So if we were making a stem and leaf plot, we have 60s, 70s, 80s, 90s, 100s, 110s, and 120s. So stem and leaf, we will write down the stem as the 10 and the leaf as your ones. So 60, we'll just put here, 60, we got 60. 67, we already have the 6, so you only have to put the 7. 68, we've got the 6, put the 8. 68, 69, 65, 66, 67, 68, 61, 67, 68, 69. And you'll notice I don't have to put those in order. Left brain folks in the room, you will probably put 0, 1, 5, 6, 7, 7, 8, 8, 8, 9, 9. And that's fine. It all works. And then we will do the same with our 70s. 73, 77, 79, 78, 77, 76, 375, 77, 1, 2, 379s. And then you would put your 80s, you would put your 90s, and so on. And the cool thing about a stem and leaf plot is you can go back and you can recreate your data. So looking at our data, I could read that and say 60, 67, 68, 69. You can get your original data. There's also a plot called a dot plot. And a dot plot will put 60s, 70s, 80s. They'll still put like your stems here at the bottom, but for 60s they'll say, okay, so we had 12 things that were in the 60s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 14 here. 11 there. 1. I forgot how many we had. But anyway, it sort of goes like that. But what I want you to know is the difference in a dot plot versus a stem plot is a dot plot, you can't get your original data. You just look at it and you go, wow, I had like 12 60s. I had like 14 70s. But we don't know what exactly they were. So that's the difference in a stem plot and a dot plot. Okay, so that's all we know about frequency tables. And then we will talk about graphing.